Okay, so our next conversation is going to be about finding the area of parallelograms, and we'll go through a little activity here. And the fun little phrase of the moment is too many numbers. So when we're looking at the area of parallelograms, we'll see that often we have more dimensions of the parallelogram than we'll need to calculate the area. So what are we going to do? Well, the first thing we're going to do is look at two new terms. These two new terms need to be recorded with definitions in the vocab section of your binder. The first of those is base of a parallelogram. And the base of a parallelogram is the distance across the bottom of a parallelogram. And again, actually this distance could be the length of any of the sides of a parallelogram. Now the real key with the base of a parallelogram, just as the base of a triangle, is that the base and the height must be perpendicular. Definition of height: the perpendicular distance between bases of a parallelogram. So you can see the base of this parallelogram is highlighted in red. We could argue, and we'd be correct to argue, that if the bottom here is a base, then the top is also a base, since opposite sides of a parallelogram are the same in length. So if the bottom is a base, then the top's the base also. And here we see the height highlighted in red, and the height would be the perpendicular distance between bases of a parallelogram. The height will always be given as a dashed line in a parallelogram, unless the parallelogram is also a rectangle, because the rectangle is the only time when the base and the height of a parallelogram would be perpendicular to each other. So a little for instance, you'll be looking for the height as a dashed line. So base and height are important for us to know. But today we're going to be looking to create a formula we can use for the area of parallelograms. We're going to use some example parallelograms to explore the dimensions and try and discover a relationship between the values of the dimensions and the value we find for the area. We're going to organize our information in a table. So you'll have a PDF file that gives you a bunch of parallelograms and a table that you won't enter information in. You'll also get a Excel file that you'll use to input your values. We're going to look, we'll do the first parallelogram together, just like we've done the first of other shapes together when entering into this kind of an exercise. So here's our first parallelogram. It's parallelogram number 1. And you can see the different dimensions that we're going to find. And ultimately, we're going to be looking for area. So we'll start with the base. The base is the distance across the bottom of the parallelogram. And we're looking at a length here, so we're going to measure the lengths. We've got 1 length, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the base of this parallelogram is 12 units. Next, we'll look at the side. And the side here, you can see the tilted grid to help you count the side. And again, the side is a length, not a number of square units. So 1, 2, 3, 4, 5 lengths is the length of the side. So we've got 5 units for the length of the side. The last dimension we're going to figure is, the last dimension we're going to find is the height. And the height, keep in mind, must be perpendicular, the perpendicular distance between two bases. And anywhere we can find the perpendicular distance is fine to count the height. You can see here I've got 1, 2, 3 units as the height of the parallelogram, but you can see I'd get the same number if I counted the perpendicular distance here, where I'd have 1, 2, 3 units. So anywhere I'm counting that height, I should find the same value. The last thing I'm going to do is count area. And again, to count area, I'm going to count the individual squares inside the parallelogram. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So I've got 30 whole squares. And then I've got a number of portions of squares. We'll start with the 30 whole squares, and then we'll look to see what we've got. Now, when we were talking about triangles, we said that portions on opposite ends of a diagonal will add up to a whole square. And that's true with parallelograms as well. I've got a portion here and the portion on the opposite end. Together, they're going to make one whole square. I've got a little corner here and most of a unit here, and that's going to make a second whole square. I've got most of a unit here and a corner here, and that makes a third. So I've got 3 whole units on this diagonal. The nice thing about this parallelogram is opposite diagonals, meaning the diagonal on one side and the diagonal on the other side, will share the same number of whole units on the diagonal. So that means I'll have a total of 3 whole units made up of the parts on this diagonal. So I've got 30, I've got 3 over here, and I've got 3 more over here, making my total area 36 square units. I've got 36 square units for my first area. The next thing I'm going to do is complete the same exercise for the other parallelograms in my on my worksheet. And again, for number 1, I've got a base of 12 units. The side length was 5 units. The height was 3 units. And the area I found was 36 square units. You're going to complete the exercise for the remaining 5 parallelograms. Once you do, you'll enter those values, the values you find, into the spreadsheet that you have. Once you have that spreadsheet completed, you'll save it and then upload to the Moodle site. When you're done with that, the next step is we're going to look at those values that you have and try and develop a formula based on the values that we found for our parallelograms. That's it for this section.